Hello, everyone. Thank you so much for inviting me to present one of my projects that I'm conducting at the University of Guelph, which is on identifying potentially novel biomarkers for the metabolic syndrome. So I'm an assistant professor at the University of Guelph, and we're going to be focusing today on the metabolic syndrome, as I said earlier. Why it's not doing next? Okay. For those who don't know, the metabolic syndrome they've been trying to define the metabolic syndrome for a long period of time. It's actually a constellation of different risk factors for cardiovascular diseases and type 2 diabetes, and it includes insulin resistance, central obesity, inflammation, hypertension, dyslipidemia, which is mostly characterized by decreased levels of HDL, increased levels of triglycerides in particular. And honestly, the metabolic syndrome has been found to be a major risk factor for cardiovascular disease, increasing the risk of cardiovascular disease by 1.5 to 2 times in general. So there were so many risk factors. They were trying to define what are the risk factors for developing the metabolic syndrome, which is a risk factor on its own for CVD and diabetes. And so many factors have been identified, and they're trying to identify more factors to date. Genetics play a role to an extent, definitely. Inappropriate diet and lifestyle plays a major role. Age, ethnicity, income, gender, they all seem to contribute in different ways to insulin resistance, to increased risk of central obesity, certain form of inflammatory markers increasing in your blood, oxidative stress. Also, there is now more involvement of the hypothalamic axis dysregulation, seems to be maybe increasing cortisol levels in the blood of individuals, which might trigger insulin resistance, which might increase the risk of the metabolic syndrome. And so all of these seem to work all together, and there are more factors that are being discussed today and even more studied today to understand this interesting syndrome. So as you can see on this slide, I tried to summarize the different definitions for the metabolic syndrome that happened throughout the years. And you can see that it started in 1998 with the WHO up to the harmonized definition, which was the latest definition for the metabolic syndrome in 2009. All over the years, there were some changes in the definition of the metabolic syndrome depending on the evidence emerging on the metabolic syndrome. But if you check the different definitions, you can see that insulin resistance is there, central obesity is important, hypertension is a big component, dyslipidemia, and sometimes also increased blood glucose levels. So all of these altogether seem to be always part of the definition with the evolution of this definition of the metabolic syndrome. Because of that, because of the increased prevalence of the metabolic syndrome throughout the years, not only in Canada, but in all developing and developed countries, this made me interested in this syndrome. Back in 2008, when I was a master's student at the American University of Beirut, we did conduct a study in Lebanon on 499 adults aged 18 to 65 years. And we did find that a big proportion of those individuals, which were we chose them from different areas in Lebanon, around 31.2% had the metabolic syndrome. And we chose the IDF for defining the metabolic syndrome, the International Diabetes Federation definition, because you have to choose one definition to define the metabolic syndrome because of the multiple definitions we have so far. So we found a big proportion of individuals suffering from the metabolic syndrome, especially from central obesity and dyslipidemia, and physical inactivity was a big also component of this whole syndrome. So again, that triggered my interest in understanding more the syndrome, understanding how we can modulate and manage this syndrome. And definitely diet was my main focus. So throughout the years, as part of my PhD and postdoctoral fellowship, I did study how we can manipulate or manage different metabolic parameters, including insulin levels, glucose levels, lipid levels, appetite hormones level, how we can manage them by changing the composition of diet. And I studied the effect of diet composition on all of these parameters, mostly in postprandial periods. And we all know that postprandial means after ingesting a meal. This is an important period to study metabolic changes because we spend a long period of time in the postprandial phase after we eat. And it seems that lipid levels changes during this period define your risk of atherogenicity or cardiovascular disease. Also, the levels of glucose during this postprandial phase define when you're going to have your next meal, define when how many meals you're going to have per day, etc. So that's why I focused on the postprandial phase when studying how we can manage metabolic parameters in the postprandial phase in individuals. And I studied individuals of different characteristics. I studied healthy individuals, individuals with hyperinsulinemia, individuals with metabolic syndrome, as well as children who were normal weight and overweight, obese. And I focused, first at the beginning, I focused on protein, high protein meals, but then I moved to protein-rich foods such as milk and dairy products in different forms. And we did find benefits of increasing protein content of meals in your diet, as well as consuming milk and dairy products in your daily diet. One thing that we couldn't find is benefits of high protein meal in individuals with features of the metabolic syndrome. And that was interesting. Like in individuals with features of the metabolic syndrome, we couldn't identify benefits for the high protein meals. We couldn't see improvement in their insulin resistance parameters. We couldn't see improvement in their appetite hormones. We saw that there is worsening. There is still high lipid levels postprandially. We saw that there's still high levels of inflammatory markers in the postprandial phase. So this made us question what's going on in individuals with the metabolic syndrome. How can we manage them better? And even how can we prevent people from becoming individuals with the metabolic syndrome? Another interesting finding from this study I conducted on metabolic syndrome individuals is that we didn't only find reported decrease in HDL levels, which is expected. We didn't only report increase in LDL particle levels or LDL cholesterol levels in particular in these individuals, but we also found an increase, an enrichment of their HDL with ApoA2 levels. And this is something that brought my attention to these ApoA1, ApoA2 markers. Apolipoproteins A1 and A2 are major protein constituents of the HDL particle. So the ApoA1 constitutes around 80% of the protein in HDL, and ApoA2 around 20%. And they all define kind of the characteristics of HDL particles, such as the role they play in reverse cholesterol transport, the role they play in blocking inflammatory processes, the role they play in preventing plaque formation, preventing oxidative damage. So it seems that they do play a role in defining the characteristics of this HDL particle. But not many studies have focused on their individual roles in these different diseases that I'm interested in, such as the metabolic syndrome. And that's why I was interested in exploring these two apolipoproteins, particularly ApoA2, which is not heavily studied. What do we know so far? And based on this, I was like, okay, we need maybe to study more these two apolipoprotein markers. ApoA1 seems to be, over the years, they were able to show cardioprotective properties for this apolipoprotein. They saw that people with type 2 diabetes or metabolic syndrome, they have reduced levels for this apolipoprotein. They have some polymorphisms in the gene of this ApoA1. They have some it doesn't function normally in those individuals. For ApoA2, it's more contradictory findings. The levels of ApoA2 in people with metabolic syndrome, some studies showed it increased, one study showed it decreases, others show it doesn't change. But for, let's say, ApoA2 role in atherogenesis, it seems that it has protective roles in reducing the risk of CVD, and low levels of ApoA2 are associated with increased risk of CVD. And also there were some suggestions for genetic link between ApoA2 and type 2 diabetes and familial combined hyperlipidemia. But again, it wasn't specifically a link with the gene of ApoA2. It was more related to the chromosome or region coding for ApoA2. So I felt that findings are still not conclusive, especially with respect to these markers and the metabolic syndrome, and more studies are needed. That led me to this research question. One of my research questions is to identify novel biomarkers different than those traditionally defined ones and traditionally defined features to characterize individuals who are at risk for the metabolic syndrome. I want to know if we can use those markers to identify people at risk rather than wait until they develop the syndrome and then have to deal with drugs and pharmacotherapy and diet therapy, which might take a long time. And I thought of these markers, they might be easy to measure and they can give us an idea if someone is at risk or not. Why I thought of all of these questions, again, this is what I was trying to say. I want to understand the role of ApoA1 and ApoA2 and other apolipoproteins in the pathophysiology of the metabolic syndrome, and see how we can modulate, change their levels to make people less at risk for the metabolic syndrome. Why I'm looking for novel markers? Because so far we've been seeing that there are so many definitions for the metabolic syndrome. People use different definitions, different ways to assess it. And despite that, there is still an increase in the prevalence of the metabolic syndrome. There's something missing. We're not being able to assess accurately who is at risk and who has the metabolic syndrome. And the whole process of measuring different risk factors, different components, it's a little bit cumbersome. So we need markers that can be easily measured, accurate, predictive, that can detect the risk at early stages. I'm going to share with you today some data from a pilot study I conducted in collaboration with the Guelph Family Health Study. The Guelph Family Health Study is a cohort study. It's a huge study that follows parents with their children throughout the years, and they're measuring a large number. They have a large number of participants, but I was able to assess some anthropometric data and dietary intake data and biochemical data in 25 children and 89 adults. Because we couldn't find, because 25 children is it's a small sample size, I'm going to show you the data on the 89 adults. But again, I want to remind you that this is just, these are just pilot data, and we're trying to assess a bigger sample now so that we understand the role of ApoA1 and ApoA2 in the metabolic syndrome. Based on this table, you can see that irrespective of the definition we use to define the metabolic syndrome, we did find that levels of ApoA1 were higher and the ratio of ApoA2 to ApoA1 were lower in individuals with the metabolic syndrome. And this led us to so the levels were higher for ApoA1 and the ratio of ApoA2 to ApoA1 were lower, which indicates that there's something going on. There are some abnormalities in the metabolisms of these apolipoproteins happening in individuals with the metabolic syndrome. We did also some correlation analysis, and also we saw that ApoA1 levels positively correlated with different features of the metabolic syndrome, including glucose, C-reactive protein, which is an inflammatory marker, waist circumference, and the ratio of ApoA2 to ApoA1, it correlated negatively with features of the metabolic syndrome and positively with HDL cholesterol levels, which is a good thing. So it seems that there's something with the ratio of ApoA2 to ApoA1 that we can use to identify people at risk for the metabolic syndrome. Even when I conducted some regression analysis, similar to what I found before, ApoA2 to ApoA1 ratio was the only significant predictor for the metabolic syndrome and its components. It was a negative predictors for blood pressure, blood glucose, serum triglyceride, and the metabolic syndrome itself, and it was a positive predictor for serum HDL levels, which is again a good sign. This kind of markers stood out and made us think that it seems that we need an optimal ratio between ApoA2 to ApoA1 is needed in order to have lower risk for the metabolic syndrome and then lower risk of CVD and type 2 diabetes, etc. And this is just like an illustration of how we thought this can happen. It seems that all of the features of the metabolic syndrome will induce either at the genetic level or like translational levels. There seem to be increased levels of ApoA1 above the normal. ApoA2 seem to either decrease or stay the same, which lead to a decreased ratio between ApoA2 and ApoA1 in the HDL particles, and this will definitely affect lots of properties of HDL, including reverse cholesterol transport, inflammation, antioxidation properties, and others. So we want to have a good optimal ratio between ApoA2 and ApoA1 to make sure that HDL particles are functioning optimally. So again, I showed you data on adults. We need to confirm these findings in a larger sample size, including children and more adults, and we're expecting more significant findings to be seen. Yeah, that's it. Thank you.